Hello children, so we are continuing vector basics. We have just started vector addition and we have seen triangle law of vector addition. Okay, we are just seeing graphical approach now. Analytical approach we will be doing in the coming sessions. So graphical approach, just by drawing vectors we will be doing. So triangle law of vector addition. Suppose if a vector acting like this is head of the vector, another vector is acting in this direction. So head of one vector is connected with the tail of another vector. Then the effect of these two vectors will be in what direction? So third side of the triangle in the opposite order. So suppose the effect of these two vectors, we call them resultant. So the resultant vector is nothing but vector A plus vector B. Okay, this is what is triangle law of vector addition. So when we add scalars, okay, say for example 1 liter milk plus 2 liter milk, this is equal to what? 3 liter milk. Okay, always this is going to give us unique answer, nothing but 3 liter milk. But suppose if one person is walking 4 meters east, okay, again 3 meters east. 4 meters, suppose a person walked 4 meters in east direction and again 3 meters in east direction, then we will write the displacement will be what? 4 plus 3 is equal to 7 meters east, we can write. Okay, displacement we just added. Another possibility, suppose 4 meters east, then 3 meters west. 4 meters east and 3 meters west. Already we have seen the definition of displacement. Displacement is the shortest straight line path from initial position to final position. So if this is the initial position, if 3 meters west, if it comes back, this is going to be the final position. Displacement is 1 meters, and what will be its direction? So initial position and final position, this displacement will be in this direction, final position. So he will be walking back, correct? Displacement is 1 meter. Now suppose a person walked 4 meter east and 1 meter north. 4 meters east and 1 meters north. What will happen? 4 meters east in this direction, then sorry, we will put 3, same, all the values are same. So 3 meters north, so 3 meters north. So what is the displacement? This will be the displacement, correct? So what about this value? This is hypotenuse, 4 square plus 3 square, 16 plus 9, 25, root 25, this is going to be 5 meters. So one value, displacement, same, 4 meter we used, 3 meter we used, we got 7 meter as displacement. Here also we used 4 meter and 3 meter, but we got the displacement as 1 meter. Here also we used 4 meter and 3 meter, but we got displacement as 5 meter. So this is the maximum displacement possible. the angle between the vector is 0, and this is the minimum displacement when the angle between the vector is 180 degree. So suppose if the angle between the vectors is between 0 and 180 degree, we got intermediate values. Okay, so all these things we will discuss in detail further, but I am telling you the addition of vector or the resultant value of a vector can have different results for different directions. If the direction of the vector changes, we will get different values. We will understand like how to calculate that. Even if the complexity increases also, these things are easy, but we should have proper understanding. 1 liter milk, 2 liter milk, if you add from bottom, if you add from top, if you add from side, whatever way we do, we'll be getting 3 liters milk only. But here the value changes. Okay, so this is what is vector algebra is different. So we have seen triangle of law of vector addition. Now today we will start with the parallelogram law of vector addition also. Okay, so study of vector algebra needs concentration. Why? Because based on the angle of vectors, the result is changing here. So dear students, this is parallelogram law of vector addition. So read the definition. If two vectors are represented by two adjacent sides of a parallelogram in magnitude and direction joined tail to tail. Okay, this is just like if this is vector A, another vector, so this is tail of A, so to the tail of A another vector, say B, so tail to tail joined. Two vectors are represented by two adjacent sides of a parallelogram. So if we extend this like this is a parallelogram. Okay, parallelogram. So two vectors are represented by two adjacent sides of a parallelogram in magnitude and direction. This length is magnitude, and it's where it is pointing, that is the direction of vectors. Joined tail to tail, then the resultant is given by the resultant. Okay, the result of these two vectors, that is if we add these two vectors, the resultant is given by the diagonal of parallelogram. So which is the diagonal of parallelogram? This is the diagonal of parallelogram. Okay, it is bended a little. Okay, so diagonal of the parallelogram, just like this. Okay, and in magnitude, this length will be the magnitude. Direction also, this will be the direction, starting from common intersection of two vectors. So this is the common intersection of two vectors. This is what is parallelogram law of vector addition. Okay, this is the result of this law as well as triangle law of vector addition. Both will be same. Okay, it cannot be different. Okay, both are just different laws, but when we add two vectors, definitely we should get the same result if we put the correct angle between the vectors. So if the angle between two vectors is theta, okay, theta, and vector A, vector B, if we draw like this, then if we extend this into a parallelogram, then the diagonal of the parallelogram will be the resultant of the two vectors, and this resultant is at an angle alpha with the horizontal vectors. Okay, so direction of resultant will be mentioned using the angle alpha. This is what is triangle law of vector addition. Now how this is similar to this is parallelogram law of vector addition. How this is similar to triangle law? See, I have drawn vector A here, and you all know what is parallel shifting. We can place vectors anywhere without changing the direction and magnitude. So this vector, if I take and if I put here, so same way this B I am going to connect here. So triangle of vector addition was like this: vector A its head will be connected to the tail of vector B. This is triangle law of vector addition. Now this is the resultant. So same way, same resultant without changing the direction and magnitude, if we draw, both are same. These both are same. Okay, so triangle law of vector addition, if we measure this length and if we measure this angle, whatever length we are going to get, whatever angle we are going to get, same result we are going to get using parallelogram law of vector addition also. Okay, note it down. So if two vectors are adding, okay, at some particular angle, say if this is vector A and if this is vector B, so this could be vector A and vector B. This is also possible. This theta is some angle, arbitrary angle. This theta here it is 90 degree. Only condition is it should be joined tail to tail. Okay, that is the only condition. So suppose if we get a question like a vector is acting 3 meter east and another vector is acting 4 meter north. Okay, 3 meter east and 4 meter north. So while with the triangle law of vector addition, what we did, this is the resultant. So this resultant is nothing but root of 3 square plus 4 square. Okay, we were getting 5 meter, and this angle, this is nothing but alpha or theta, whatever we want we can put, this using triangle law of vector addition. So if this is generally this triangle, you can remember this triangle, you can remember if this is 4, if this is 5, this is 3. This triangle you must remember. Okay, 3, 4, 5. Then this angle is going to be 53 degree, and this angle which is opposite to 3 is going to be 37 degree, and obviously this is 90 degree. You can remember this angle, this triangle. Okay, so in this way, if this is 4 meter, this is 3 meter, then using sin alpha or cos alpha or tan alpha, okay, using tan alpha, 4 by 3 will be getting alpha is going to be tan inverse 4 by 3. Its angle is nothing but 53 degree. So triangle law of vector addition, using triangle law of vector addition, we can find that same thing. Okay, if this is 3 meter east and since this is 4 meter north, instead of placing here, okay, it is separately given, okay, 4 meter north. So how we can arrange if we need to solve this using parallelogram law of vector addition? Instead of placing here, we will have to place here. So this is 4 meter north. Now extending parallelogram, rectangle is another form of parallelogram. So this diagonal is going to be the resultant. So again, this is going to be what? If we need to use this, okay, if we can do parallel shifting, or if we measure this, if we using a scale, if we measure this diagonal just like this, we are going to get this as 5 meter only, and if we measure this angle, we are going to get this as 53 degree. Now there is formula for this that we will derive later. Now I am just showing this using graphical analysis. Clear? See this question. Vector A has a magnitude of 10 units and points due west. Vector A. Okay, vector A has magnitude 10 units and point due west. Okay, so this is vector A. Okay, and vector B has same magnitude and points towards south. Okay, this is vector B, 10 units and this is pointing due south. Find the magnitude and direction of A plus B. Okay, find the magnitude and direction of A plus B. So graphically, in whatever way we want, we can do, whether triangle law of vector addition or parallelogram law of vector addition. So if it is triangle law of vector addition, this is vector A, which is 10. So triangle law of vector addition first we will do. Same, both will give same answer. So this is vector B, again 10 units. So the resultant will be closing the triangle. In which direction? In this direction. If we put this direction, that is wrong. Okay, this direction. So what about this side? This side will be root of 10 square plus 10 square. Okay, root 200, or we can say 10 root 2. 10 root 2. So if we try to find this angle, tan alpha is nothing but opposite side by adjacent side. 10 by 10 is equal to 1. So alpha is equal to tan inverse 1. So for what angle we will be getting the answer as 1 for 45 degree. So this angle is nothing but, this is actually 45 degree with respect to horizontal. Okay, suppose if we need to represent the same thing using parallelogram law, so A is equal to 10 units. So instead of putting this here in as a tail at the head of A, what we will do, tail to tail we must join. So where it will come, this vector will come here. Okay, vector B, again 10 units, same. So if we close this, then this diagonal will give us the resultant. If we measure this, again we are going to get 10 root 2 only. This is alpha. If this vector we can place here, okay, using parallel shifting, again we are going to get the same answer. Clear? Note it down. Okay, now B. Okay, so specify the directions to due west. West means this is the direction. So the 45 degree which we have given is with respect to this horizontal vector, which is nothing but west. Okay, now A minus B. So A is this is A, and B is this. Okay, now A minus B. So A is this. Okay, this is vector A, 10 units. A minus B. Okay, A minus B is, so A minus B is nothing but vector A plus minus of vector B. There is no direct subtraction in vectors. What we do is we will flip the direction of the vector which is to be subtracted, then we will add, then remaining process will be same. So this is plus B vector. If we need to put minus B, what we will do, without changing the direction, without changing the magnitude, we will flip it. So this is going to be minus B. Again 10 will be the magnitude. Okay, minus B is equal to 10. So this is the vector B now, which is again 10 units. Okay, so what we can do, so if we extend this to a parallelogram, this will be the diagonal. Okay, so if we measure this, or if we place this vector here, again root of x square plus y square, so we will be getting 10 root 2. But the only thing is, this angle is going to be 45 degree. In the previous example, if this is vector A and if this is vector B, this is the resultant. We can say this 45 degree is south of 45 degrees south of west. We can say 45 degree south of west in the previous case in A. But here, so in this case we can say the angle is 45 degree, or the direction is 45 degree north of west. Okay, so this is 45 degree south of west, this is 45 degree north of west. Magnitude is same, only direction is changed when we subtract, like A minus B. So we can write like A plus B. The magnitude of A plus B is equal to magnitude of A minus B. Okay, magnitude of A plus B is equal to magnitude of A minus B, but vector A plus vector B is not equal to vector A minus vector B. These both are when A is perpendicular to B, or angle between A and B is 90 degree. A case in which if two vectors are at 90 degree, okay, if this is vector A and if this is vector B, okay, then the A plus B, if we add the vector, if we subtract the vector, that won't be same, but the magnitude will be same. Okay, just the previous example is the proof for that. Note it down. So next law is polygon law of vector addition. So triangle law and parallelogram law we use when we have two vectors. If we need to add two vectors, we can use parallelogram law or triangle law of vector addition. But in the case of more than two vectors, okay, so many vectors are acting, and if we need to get the resultant of all those vectors, then we will have to use polygon law of vector addition. Say for example, if we have some vectors acting, suppose if this is vector A, okay, this is vector A, and if we have vector B is in this direction, vector C is there in this direction, vector D is acting in this direction. So in so many vectors are there, so its resultant is going to be A plus B plus C plus D. So what will be its resultant? Okay, so in this kind of situation we will have to use polygon law of vector addition. So instead of saying statement, I am directly giving you the idea how to do this. So take vector A. Vector A. Just like in the case of triangle law of vector addition, we need to place the tail of next vector at the head of A. Okay, we need to take the next vector. Say for example, suppose if we are taking B, place the B, tail of B at the head of vector A. So vector B we have done. Take vector C. So this is vertical. So using parallel shifting method, take vector C at the head of vector D. Now vector D. So vector D, just like this, we can take vector C like this, okay, at the head of vector B. Now vector D, look at the direction. So without changing the direction and magnitude, place vector D here. So this is vector D. So all the vectors are covered. Now just like triangle of vector addition, cover this, cover this all vectors with the opposite side in the opposite order. Okay, cover the vectors just like we have covered a triangle, cover this polygon or hexagon, whatever it may be, in the opposite order. So this is what is the resultant. So any number of vectors if we get, just join tail to first to head of the last vector. Okay, just join tail to the head of last vector. Okay, likewise we can do for polygon. This is just extension of triangle law of vector addition. Okay, graphically we just need to understand, that's it. Clear? So any number of vectors if we get, arrange them with the tail of one vector on the head of another vector and arrange like this, then finally close the triangle. We can choose vectors in any order we want. Okay, if we want we can choose the vector here first. Okay, then but it should not make the things difficult, that's it. Okay, in the order we want we can do. Finally this resultant we should get, that's it. Next point which we need to study is vector addition. Vector addition obeys commutative law. Vector addition obeys commutative law. Say for example, commutative law is nothing but vector A plus vector B must be equal to vector B plus vector A. Okay, vector A plus B must be equal to vector B plus vector A. Suppose if this is vector A and if this is vector B. Okay, so one side, okay, just for example vector A plus vector B if we need to do. Okay, so first we will draw vector A, then here we will draw vector B. So this is the resultant. Okay, so vector A plus B. Okay, if this is vector A and this is vector B, generally we will be getting the resultant in this direction according to parallelogram. Now we have used a triangle law here. So vector A, vector B, we are getting the resultant here. Now we just need to see vector B plus vector A. Vector B plus vector A. So first we will draw vector B. This is vector B. Now vector A. Vector A. Now what will be the resultant? The third side of the triangle in the opposite order. This is resultant. So both are same. Both are same in magnitude and direction. So vector addition obeys commutative law, we can say. Okay, so resultant is A plus B as well as B plus A. Both are same. Okay, this is also resultant. This is also resultant, and we get the same result. Another point is vector addition is, the previous we have studied commutative. Vector addition was commutative. Now vector addition is associative. Vector addition is associative. So what is associative means? A plus in bracket B plus C. Okay, the result of B plus C when we add with the vector A, this will be equal to the resultant of vector A plus vector B. This resultant if we add with the vector C, both will be same. That is what is vector association. Okay, suppose if this is vector A, this is vector A, this is vector B, and we need one more vector which is nothing but vector C. So I am going to draw like this. So this is vector C. So what is the resultant? The resultant will be this one. Polygon law of vector addition we have seen. Okay, now what we need to see? We need to see vector A plus the resultant of vector B plus C. So what is the resultant of vector B plus vector C? Definitely a triangle like this. So what that also we will draw. So vector B and this is vector C, and the resultant of vector B plus C will be in which direction? This is what is the resultant of vector B plus C. We can say vector B plus C is this, using triangle of vector addition. Now if we take this B plus C, and if we are adding vector A with this, now what is the resultant? This resultant is same. See, this is the resultant. So this one and this one are same. Just while drawing, magnitude became a little bit less, but I shall correct it. Okay, we should be careful in this, but direction is same. If I draw it correctly, I will be getting the same length also. So this is the resultant. When I do like this, I am getting that. Now this is nothing but actually A plus vector A plus B plus C. Okay, now we will do this. What is the resultant of A plus B? This is A, this is B. The resultant will be like this. So that also we will draw vector A, and this is vector B. The resultant of vector A plus B is this. Now this one, if we add with the vector C, okay, that we will see here. So this is vector A plus B. Where is vector C? Vector C is here. So that we are going to add like this. Okay. So this is vector C. Now what we are getting? We are getting the resultant, which is in this direction. Okay. So slightly angle appears to be changed, but the same only. Okay. So all the resultants are same. Okay. So vector addition is associative. This is also proved just graphically. Resultant is same for A plus B vector plus C vector, or A plus B vector with the C vector. It is not going to change. Clear? So how to add vectors? Using triangle law, using parallelogram law, and using polygon law. Okay, and whether they are associative, commutative, graphically how we can see the angle, all those things we have seen. Now we will have to see the analytical method also, so that we will be using formula for finding the resultant of a vector and the direction of a vector also. Okay, that we will see in the next session. Just keep on revising it. Okay, just be comfortable with the vector algebra. Slowly we are moving. So throughout physics, this fundamental is very important. Okay, without sound basics in vector algebra, we won't be able to score well in physics. Okay, so just revise it, just be in touch with the vectors. Okay, slowly we will accelerate. Okay, now things will come very fast. So just I'm just giving a feel of vectors. Okay, making you comfortable with the vectors. Okay, so please focus on the studies. Okay students, goodbye, good luck.